All right, is this count? Are we recording? Are we finishing week 13? So here's where we're at. April 11th, finishing week 13. Thursday, April 13th, we start week 14. A week from today is the last lecture, ending week 14. We'll have a homework assignment most likely due on the 18th. So just as a heads up, which will be on a Tuesday, a week from today. So you have a homework assignment due Thursday and one due Tuesday. And I'll explain more on Thursday about the one due on Tuesday. It won't be that hard, it won't be that long. And then you have all the way then a whole week from the 18th to the 25th, because your exam is on the 25th at 11:30 a.m. Here's week 13's instructions. Don't forget there's two parts to this week's assignment. There are these 21 references, and it's been brought to my attention, which I think I already noticed anyway, that there are maybe two of the same references there. Just put the same information, just ignore that it's on there twice. I think it says outliers in one spot, and it says graphing outliers in another. I think those are both outliers or something. I'm not sure if there's a difference or not, but put whatever you want. Like I said, the only way you can get this wrong on the references is if you don't put anything. Because you want to put some good references there because you're allowed to use this during the final exam. You take a picture of it and have it as part of your notes that you're going to have in front of you while you're taking the exam. Also, we have the written Excel part of the assignment. Let me show you that. Whoops, there's the references. Here, real quick, how many pages? 1, 2. That's it, just 2 pages? 1, 2, so just 2 pages. And then, here's the assignment. You have 1 A and B, 2 A and B, 3 A and B, 4 A and B. Now, I prepared you for half of this assignment last week on Thursday because you learned how to do proportions. In between two proportions, called an interval between the proportions. Today's all about intervals between the means with standard deviations. But I kind of gave you a big heads up how to do this, so it should have been pretty easy. Is there anybody that happens to have the homework done? The camera can't pick up all those hands back there. Darn.
It's all.
It's all what?
It's all.
I can't hear.
It's up.
It's up?
Yeah.
Oh, the hands? Yeah, that's what I'm getting on the recording. That there's looks like about 32 hands up on the other side of the camera. Because nobody's willing to sit in the front row. Right here. Anyway, we only have 2 more lectures after this. I don't know what I'm doing now other than just having fun. Thank you, David. And here's your in-class assignment in case you want to get started. All right, I have enough of that. So, you want to talk about the exam real quick before we go on to the new stuff? Does anybody want any questions about what to expect on the exam? How long it's going to be? Anything like that? Yeah, go ahead.
We study everything from the beginning of the semester.
Everything from the beginning of the semester. What did I mention? What percent would be the newer material, and what percent would be the old material, though? Seriously? Yeah. Do you remember? Stephen, number 2.
40% is the original.
That's right. Very good. About 40% would be the old material from quiz 2 back. I thought that was Cole that said that, though. Just saying. And 60% probably the new material. It might be 55%, 45%, but a little more will be the new material from after quiz 2, and a little less will be the old material going back. But then the hint was on the old material that it would be mostly the main subjects that I really emphasized in the lectures going back to week 1. Good.
Did you write down the main subject?
Can't hear you.
Did you write down the main subject?
Did I write down the what? No, I can't write down the main subjects, but I know what I did do is I posted practice problems. This is the first semester I put together practice problems. Thank you, Olivia, for pushing me to do that. I appreciate it. So you guys have practice problems that are posted in announcements, I think. Does that sound right?
Yeah.
Okay. So you got those. And also, don't forget, if you show up on a week from today, the last lecture, I'm going to give what hint? Does anybody remember? No one remembers? Seriously?
Extra credit?
No, there's no such thing. No such thing as extra credit. Don't forget, I have a list prepared of subjects not to study. Remember? So that you can, what I'll do is I'll put it on the camera so you just take a picture of it. So you have a list of the subjects that you know not to study. So it'll at least narrow it down a little bit. Like I said, I have not started the final exam writing it. I write a new one every semester. So, I mean, I look at the previous semesters just to see how many questions there were, how many points, and stuff like that, to try to make sure it's consistent, but does anybody remember how many questions we should most likely expect and how much time?
15.
50 questions?
15, 1-5.
Oh, that sounds about right. 15 questions, 16 questions, 14 questions, somewhere in there. What about time, Yusuf? How much time do you think?
2 hours?
Twice as long.
About twice as long as a quiz, and quiz 2 was an hour, so that makes sense, it'd be 2 hours. But if it's only like 14 questions, maybe it's only an hour and 50 minutes or something like that. That should be your expectations. What time do we start? 11:30. I know you think 11. Somebody's gonna show up at 11 because that's usually when class starts, but it's 11:30. You don't have to be here. Come to 11 if you want. Because you're gonna look at the seating chart, you're gonna start downloading all your stuff off of Canvas at whatever computer you're sitting at, unless you're bringing your own laptop. Just like quiz 1 and 2, no surprises, no shocks. I'm gonna try to make it a little hard. I still gotta separate those A's from the B's and the C's. All right, are we ready for some new material and some life lessons? You want a life lesson?
Yes.
You do want one? Here it is. So you know. That was just to get your blood moving. All right. Today, it's really easy because it's almost like reviewing the old stuff when we were using the mean and the standard deviation to find the probability of something or less or something or more, right? Just like it. The only difference is now you're finding the probability between two numbers, and so you got to do the equations twice. You got to do it for one number, then do it for the other number, get the two z's, use norm S distribution to find the probabilities, then subtract the probabilities. Everybody hear that? So, we're going to start out with this. I want to remind you, in the story that we've used so many times this semester, you are the director of admissions. You have 900 people that have been accepted to the college. You are going to that meeting again. Remember this? You're going to that meeting. You are asked to bring the mean SAT score and the proportion of those who said yes, they want to live in student housing, so the student housing director can prepare. Does it sound familiar? You've heard it so many times. We're focused on that SAT score. We walked into that meeting and we said, based on our sample size of 30, the average SAT score was 997. Now, time went by. We got all 900 applications in the system, and we found out that it's really 990. Look at us. We walked in with only 7 off from the real one. Now, just like last week when I talked about what were the possibilities of us walking in, reporting 68% from our sample of 30, and then all 900 got in the computer and ended up being 72%. Do you remember when we had a sample of 30, our odds of this happening were so low that we decided it was lucky that we walked in the meeting with that score. So now my question is, what were the odds of us walking in the meeting only being about 7 off? Matter of fact, that's kind of off really. I want to find the probability of us being 5 above or 5 below the actual 990. We walked into that meeting with what % chance that we're going to report something at least darn close to 990? I mean, it's after the fact. You remember, in real life, we don't know that it's 990. We don't know it's 72%. We haven't entered them in. So we don't know what the probability is of us walking in with a good number or not. We only find this out after the case. After we get all 900 entered in is when we can find out. What we're learning from this, though, by calculating this probability of what were our odds walking in with numbers that were close to the actual numbers, is that we are hopefully learning that we didn't have a sample size large enough for this meeting. We should not have used 30. That's what we should be getting out of this. That our sample size should have been larger because as managers, you don't want to walk in with a 40%, 50% chance of reporting a number that could be close. You want to have more like a 70% chance or an 80% chance of reporting a number that's gonna be close. So I think when I said, hey, give me a sample size, let's see how we can get the percent better, I think Ahmed, who speaks up a lot, thanks Ahmed, said 150, true? Is that true? 150, and it got us much closer. I don't remember what percent it got us up to, but you said you'd like to be at 80% if I recall, and it only got us up to maybe 75 or 79 or something, but still, much better probability that we're reporting something a lot closer to the actual number. So now, here's my question. We're gonna calculate what's the probability, what was it when after the fact we find out it's 990, what's standard deviation? 80, right? So 80 is our standard deviation. I wanna calculate what we did by only doing a sample of 30, what the probability was of us walking in somewhere between, I wanna go 10 above and 10 below. Because we walked in with 997. I know I said a minute ago 5, but I'm gonna go 10. 997 was 7 away. Did we get lucky again, or were the odds in our favor? Did we have like a 60, 70, 80% chance of walking in with that? That's what we're gonna look into. The deal is, here's the equation. Let's remember that equation. X minus the mean over the standard deviation. I never use symbols, sorry. STDEV, standard deviation, over the square root of sample size. There's a refresher on the formula. So now we know our denominator here is going to be 80 is the standard deviation. Our sample size was square root of 30. There's our denominator for this whole calculation. Let me repeat the question. What's the probability we were within 10 above or 10 below the actual 990 when we walked into that meeting with a sample of the results from a sample of 30? Here's what I'm asking. A 10 above would take us to 1,000. 10 below would take us to 980. There's the two numbers. So now, just like last week with proportions, we're now with this mean and standard deviation, I'm going to do this twice. 980 minus 990 divided by 80 over the square root of 30. Hang on, let me do it once here. 980 minus 990, parentheses, over 80 divided by the square root of 30. There's 1. 980 minus 990. The second one's going to be the other number. 1,000 minus 990. Still using the same mean. 80 over the square root of 30. Let me repeat what I just said for those who can't see this way down here. I took the 980 minus the mean of 990 divided by the standard error. 80 over the square root of 30. I'm going to get that Z. I do it again. 1,000 minus the mean. 1,000 minus the mean of 990. Look at the bell curve. When I get the results from 1,000 or less, from 980 or less, which result do I subtract from which result? Which one's going to have the bigger probability? Which one's going to have the smaller? The 980 or the 1,000 is going to have the bigger. Which one? The bigger probability when we get to the end of this. Look at the bell curve. Say it, Stephen. I thought you said it. Oh.
1,000.
Say it again.
1,000.
The 1,000. The 1,000 will be bigger because look, 1,000 or less is going to be this much of the bell curve from here over. 980 or less is only going to be the tail of the bell curve. Now I don't have my numbers in the exact right spot, but you can easily tell that 1,000 is going to be a bigger one. So once I get this bottom Z, and I then use, here we go, equals norm SDIST parenthesis parenthesis. I'm putting Z right in there. Once I do that and get the probability for 1,000, and then I do it again and get the probability for 980, I subtract the two. The 1,000 is going to be the bigger one, and that's the probability between two numbers. Now in this case, here's the deal. I happen to be using two numbers that are exactly the same distance away from the center. And so I only need to calculate the Z once, because the other one will be the opposite Z, the negative. So if I calculate Z for the 980 or the 1,000 and I get a positive number, I don't need to calculate this one. It will be the exact same Z but negative. Or if I do this one first and get the negative Z, I know this one will be the exact same Z but positive, because they're exactly the same distance away from center. Don't get me wrong, if this is on your final exam, and it will be, long pause, if this is on your final exam, it's not going to be two numbers exactly the same distance away from center. They could be both over here on this side, they could be both on that side, they could be at different distances away from center. I'm not gonna make it that easy. I wanna make sure I can see you can do this. This is one of the most important things in the new one. When you get into 302, probably in about week 3, you're gonna be doing what's called confidence intervals, which are almost exactly like these, except they are equal distance from, called confidence intervals. And so you're gonna go, wow, this sounds familiar, hey, I can do these. And it's gonna keep your confidence up, because 302 gets hard for a lot of people, sometimes. So I wanna make sure you get these. This is gonna be on your final. I'm preparing you. This is all about preparing you. And next week, week 14 is all about preparing for 302. Because in 302, and operations, you're doing quality control. And so that's what the subject's gonna be on next week's, this Thursday and Tuesday, is quality control, preparing you for 302 in operations. Because you're gonna go more in depth than what I'm covering on quality control. I'm keeping it easy for you guys. We're just using 3 standard deviations to figure out our control numbers. But you're getting into a lot more of it in the other classes. So it's gonna be easy. You're gonna finish with some easy stuff on week 14. Are you ready? Here it is. Here's the math. Let me get to it. Here's the 80 over the square root of 30. This turns out to be 14.6? There's our denominator. The numerator, 980 minus 990. This one's a negative 10. This one's a positive 10 over 14.6. They're the exact 2 same numbers. So here we go, 980 and 1,000. 1,000 minus 990 divided by 14.6 is 0.68. Equals 0.68. That is our Z. The other Z is negative 0.68. We look up 0.68 on the Z chart. No, we don't look up the 0.68 in the Z chart. We use norm S distribution. Here we go, 0.68 equals NORMSDIST 0.68, parentheses, 0.751748. So 75%, I'm gonna round, I know I should go more digits. Let's see, this one is 75%. Minus the other one, now look what I have to do. All I gotta do is put a negative in front of this 0.68. There it is, same Z. 25%. You ready? The probability, let me get back to this PowerPoint. What we just calculated. The probability, let me go here. Here it is. 1,000 minus 990 is the 0.68. We look it up on the Z chart, 75%. Then we do, here's the other one, 980 minus 990 divided by 14.6, which is 80 over the square root of 30, is a negative 0.68. That's 25%. 75% minus 25% is 50%. What we just found out is, excuse me, we walked into that meeting with only a 50% chance of being that close to the real SAT score. Go ahead, Ahmed. Ahmed, did you have a question?
Yes, so for the 80, how did we get 80? Is it like, was it given?
The 80 was given. After we entered all the, let me go back to it. Excuse me. After we put all the applications in, we found the standard deviation to be 80, and the, excuse me, I'm choking on something went down the wrong tube here. And we got 80 for the standard deviation. And then we also did a sample size of 30. So that's why we have 80 divided by the square root of 30. All right. Now, I want you to see some that where the numbers are not exactly the same distance on either side. So you can see how the calculations go. Just the only difference is that you do actually have to do 2 calculations because you're going to get 2 different Z's. You're not going to use 0.68 and negative 0.68. They're not going to be the exact same distance away. At least I think, if I have that correct. So, we're looking at number 8. We're on my pointer right now. By the way, I can't remember what page this is on, but it's, no, it says page 259. I don't know if that's true or not. Someone might check. But it says, number 8 says, a random sample size of 100 is taken from a population with a mean of 80 standard deviation of 14. Then I want you to go to B. What's the probability that the sample mean falls between 77 and 85? 77 and 85. Here it is. 85 minus the mean of 80 divided by the standard deviation of 14 over the square root of 100. You ready? The other one, 77 minus 80 divided by 14 over the square root of 100. You just gotta do both of them, get both C's. Here's both C's. 85 is 3.57. 77 is negative 2.14, so this is gonna have the bigger probability. So I wanna find that probability and subtract this probability to find the probability between them. Here I go. Whoops. Come on, I gotta put it back. Okay, equals norm. Oh, you know what I forgot? This is solve it using Excel. Norm S distribution. The first one is 3.57. 3.571/4. There it is. About 99%. Wow. Is that what it is? Is that almost 100%? That's about 99.9%. Or more, actually. The other one, equals norm S distribution, negative 2.14, 286. So all I did is I took one number minus the mean and the other number. What's the probability between 85 and 77? This one is that 1% or 1.5%? 1.6%. You subtract the two and you find the answer between them. Now, let's do this one. We're going to solve it using norm distribution without the S. This is part B. Go ahead, Adam. This is part B. You ready? Can someone? This is going to be, I'm going to go fast. Equals NORM dot DIST parentheses. What's my first number? Anybody know? Can't hear you. 85 it is. Very good, David. Comma, what's the second number? 80, very good. Comma, here we go. 14 over SQRT, parentheses, 100, parentheses, comma, what's the last number? 1 it is. Now, I can hit enter, and we find the probability of 1, but I'm going to do it all in one equation. So I'm just hitting minus, no equal sign now. The second one, you just got minus NORM dot DIST, parentheses. Everything's the same except for the first number, which is 77. 77, comma, 80, comma, 14 over SQRT, parentheses, 100, parentheses, comma, 1. Here it is between them. If we did this right, it should come out to be, what is that, 99.9 minus 1. So it should be about 98, 97 point something, or 98 point something. There it is, 98.376. There's how to do part B. What's acceptable is you can do two separate equations and put down both results and then show you that you're subtracting the two results if you don't want to do one equation. You can do it as two separate equations if you want. Okay, we got one more.
We do that with the other ones too, right?
Say that again. Yes.
With the other one that doesn't have standard deviation. You do the same thing, right?
Same thing, except for notice, see up there where it says 14 over the square root of 100? If this were a proportion, it would have said square root of, that whole thing. Yeah, the one proportion times 1 minus the other proportion would have had all that. That's the only difference. I know this is almost too easy homework now. You should have it done now. Okay, one more example. Here it is, number 9, C. Ready? Random sample, size 50, taken from a population with a mean of negative 9.5, standard deviation of 2. C, what's the probability the sample mean will fall between negative 10 and negative 9? The mean is 9.5. This happens to be a problem that has both numbers at the exact same distance from the mean on each side. So we don't have to calculate this twice. Negative 10 is exactly a half of a number on one side, and 9 is a half a number on the other side. But I do have it set up right here twice. Here it is, -9 minus -9.5. The two negatives turn into adding. Okay? -10 minus -9.5 is -10 plus 9.5. Look at the two z's though. One is positive, one is negative. They're the exact same number because they're exactly the same distance from the center. And then all you gotta do is enter it in. This time we'll do it separate, two separate numbers. Now I'm not gonna do the norm S's. Might as well, all I gotta do is change the number, I guess. Here we go. This time this is gonna be 1.767767. 1.767767. That's it? There's one. This one's gonna be negative 1.767. 1.767767. Did I do that top one right? Anybody paying attention? All right. And now this one. Ready? Equals NORM dot DIST parentheses. What's the first number? We're doing the negative numbers. Which number would be first? This is a tough one with negative numbers. You gotta say which one's gonna produce the bigger percentage, so it's then subtracting the smaller percentage. So should I put which number? What do you say? 9 minus 9? Let me look. Minus 9 it is. Here's the hint. The minus 9 ended up being a positive z. The minus 10 was a negative z. This is gonna be the bigger outcome. So minus 9 is the first number, comma, the mean, negative 9. Oh, what happened? I hit something. Okay, here. Negative 9.5, comma. The standard error is right there. 2 divided by the square root of 50. 2 divided by SQRT, parentheses, 50, parentheses, comma, 1. Whoops. There's one of the equations. Matter of fact, I'm going to go ahead and hit enter on this equation. Where is it at? Way up there? I hit something with my finger? There it is. That's just, notice, that is the same as this. When we put norm S distribution with the z, we got 0.96145. When we did it using norm dot distribution, we got 0.96145. Now, all I'm going to do is I'm going to copy and paste this equation right below, but I'm changing the first number to negative 10 instead of negative 9. That's the only thing that has to be changed, and we'll get the other percentage. There it is, 0.03855, just like when we used norm S up here, 0.0835, 0.03855. Now the two of them subtracted. Ready? Equals, what is that, G13? G13 minus G14. There's the difference, 0.9229. The reason these three examples were presented is just to make sure you realize how to do two of the questions on your homework, because two of them are using a mean and standard deviation, and the other two are using proportions. Go ahead.
So in the percentage, if the question has percentages, so that's where we have to calculate standard deviation, right?
Yeah, do the proportions, is that what you're talking about? Yes. Yeah, don't forget though, there's a given proportion, and then sometimes the other proportion you're being asked to find the probability of is not given to you directly. It may say, out of a sample of 60, what's the probability 3 said yes? And then you gotta calculate the proportion that you need to find the probability of. That's the only thing I want to keep to make sure you realize. But here's the big hit. This one's the only one that gives you the standard deviation. You know to use this. So the other one will never give you a standard deviation. All right. Any other questions? Is that it? Seriously? You want your in class? Wait, we got this. I forgot, right here. Wait, this is when the video ends.